guys are doing well. So continuing our journey in Kotlin. Today we will be starting with functions. So in previous chapters we've seen um, Kotlin variables, type systems and control structures. But to create applications we need building blocks that help us a lot to make structures. In Java the class is the building block of the code. In Kotlin on the other hand supports functional programming. Therefore, it is possible to create whole programs or libraries without any classes. Function is the most basic building block in Kotlin. The chapter introduces functions. So the basic functions, what we'll be learning about functions, how to define, unit at a time, var, parameter, single expression, tail recursive, default argument, named argument, top level functions, and then nothing local functions, and then nothing returned. Now basic function declaration. The most uh, the most common function program is to write a programming. The most common program to write is something that is hello world. It is a full program that displays just hello. So now he's saying what is now a function defines a single parameter. So this is the parameter, and which contains um, an array of all arguments used to run the program. From the command line, it is defined as a non-null because an empty array is passed to a method when the program is started without any arguments. Println is a Kotlin function that is defined in the standard library equivalent to system.out.println. Now this program tells a lot about Kotlin. It shows that function looks, how the function looks, and how to define a function. So let's define a function. Let's go to kotlin.org. And then let's write Kotlin playground. Okay, so the way to write a function is func, then unite function name, then you have parameter list, then you have braces indicating the block of code, then you do println, and this is hello world. Then you come down, call the function name here. So the moment you run it, you'll be printing hello world. Okay, perfect. Now a piece of code by name. Okay, the parameters. Okay, now the syntax to call a function is the same as in Java and most modern. Now remember, we call the double function and assign a value. Okay, we'll see why we can assign it. Parameters in Kotlin are used declared using Pascal notations, and the type of each parameter must be specified. All parameters are read-only. There is no way to make parameters mutable because this is error prone, and in Java it was often used by programmers. There is no need for that. We can explicitly shadow parameters by declaring local variables. So what he's saying is this is possible. But this is a bad practice, so a warning will be displayed. A better approach is to name the parameters by the data they provide and variables by purpose they serve. This should be different in most cases. So then you have A1, you pass the type. Again, Kotlin is type strict, right? Okay. Now in Java, function in Kotlin can as in Java, you have multiple. You can pass in multiple parameters in here. Okay. Now arguments provided to function can be subtypes of the type specified. As we know, everything is inherited from any. So if you want to accept all types, you can pass in any as well. Here type is not important. To allow null arguments, the type needs to be specified. or you can have nullable arguments as well. What is can have an option. This value can be null, so you need to again. Any is a supertype of all and non-nullable, so we can pass objects off. So what we can do here is, let's have this is function 2, and then you need to define the data type as this is int again, because then you have to put in 10, and then you call function 2 and pass in 10. Okay. Now, so far, most of the functions are defined like procedures, functions that do not return. When it is not specified, the default unit value is the unit instance. We can set it explicitly for demonstration purposes. Unlike in Java, we are defining the return type after the function name, and so this is by default the return type is, so here is the return type. So I can have this let this return what is the type of the data which is being returned, so that is int. So then if I come here, let's close this. Here there's nothing is returned, right? So it should give an error, missing return statement. So you come here and you return B, and then run. This is okay. If nothing is mentioned, then if I mention unit and I don't return anything, then this should work fine. By default, the return type is units. Kotlin, okay, unlike in Java, the unit object is the equivalent of Java's void, but it can be treated as any other object. We can store it in our variables. So if you want, you can. Of course, Kotlin coding convention claims that when a function returns a unit, then the type definition should be omitted. This way, code is more readable and simple. So we're saying, oh, that's how I'm getting this. So I'm saying if you are returning unit, there's no need to write this. You can ignore this, and then the moment we assign it to a set of val is, and if I print ln, now if I run it, see I get Kotlin.unit. Okay. Unit is a singleton. Okay, we'll see what is the singleton. Now he's saying some important properties. It's singleton. So double equal to, will only check the value. Oh, we haven't. Oh, we'll see next what is singleton. To return the output from function with the unit return type, we can simply use a return. So just and that's okay. Now there is no return type specified. The return is set to unit. We can return without any value. When a function returns unit, then all call is then the return call. That there is no need to write this return. You could also use the return type unit, but it should not be used because that would be misleading and less readable. When we specify return type other than unit, then we always need to return the value. So if I have something in that, then I need to return and so get an error. Okay, the function will not compile because to return value was specified the as okay. So the return is inside the bracket, right? Okay, the problem can be fixed by adding a second return statement. We have a where arg parameter. Sometimes the number of parameters is not known in advance. In such cases, we can add a where arg modifier. It allows the function to accept any number of arguments. Here is an example. The arguments will be accessible inside the method as an array that holds all the provided values. The type of array will correspond to where arg parameter type. Normally, we would expect it to be generic array holding a specified type, but as we know, Kotlin has an optimized type for arrays of int called int arrays, so this will be used. So basically what is this? Depending on the type here, corresponding array is generated. So this will now become an array. So this all will be stored in an array of text. Is that? Uh, so then let's go and do this. So now for variable I have a func fun, and then I do variable parameter, and then var args, and this is text, and then okay, so this is the parameter type, and then just mention string. So now this will be an array of strings. Println hello. Now when we run this, oh, so you haven't called this, right? So I need to call this pass in. You pass in multiple values, an array will be generated. So can I do this with this? Instead of printing this here, this is an array of strings, right? So what if I try it? Does this? Yeah, see now A is getting printed, and this is, so an array is created. This is now an array. So if I do 1, so just add in array is created. So print is a function. Now that we are able to specify more parameters before or after var, as long as it's clear which argument is, you can have one more. So it should be clear, right? Like var is which. Now additionally, arguments related to var can be subtypes, so you can have it any as well. There only one var. Okay, so we can have only one var. Why is this? Why? Okay, so the thing is, if you have multiple arrays, then it is not clear to the compiler, right? Like which array is which, and there is nothing mentioned over here indicating like which array is. I see. Single expression functions. Now in a typical programming, many functions contain only one expression. Okay, so for if it's a another one which can be often found is a pattern used in activity. To define methods, you can just get text from some view or provide data. Both functions are defined to return the results. Okay, so there is a single expression return. These kinds of functions are used all over the projects. Here are some use cases: extracting some small operations like in Okay, using poly. Okay. The such functions are often used Kotlin as a notation for this kind. When the function returns a single expression, then curly braces and the body of the function can be omitted. We specify the expansion directly. Also, there is a shortcut way. Also, this is a function. It's returning a single expression, right? We can do something like you could just have this. Change it. This is an almost modern programming. So he's saying functions with single expression return. So if this is the case, you can just do fun square and then this is x into x. Now this is same as having you pass in and then do return and then you come here, you pass in something. And then you assign this to val. And the moment you run this, oh, expect, oh yeah, you can, this is same. This is same, right? Either you do this and then, so how to call this square is using square. We haven't talked about what is saying. So he's saying where will we use it in Kotlin or in variant activity. When chain in multiple operations. Okay, so the way to call this is how to call this. This is something views, right? We haven't gone there. How to call this? Also, we can directly use this square to call. Yeah, can just say and then you do so this is 10 into 10, right? And there is no need to mention the return time because it's single expression, right? Now tail recursive functions. Now recursive functions are functions that call themselves. Let's see, these are important problem functional programming style, but the problem is that recursive functions need to keep on returning the address of the when an application is too deeply nested. This gives an stack overflow. The limitation presents a very serious problem A proper solution is using a tail recursive function. Tail recursive function is special console recursive where the function call itself as the last operation it performs. In other words, recursive takes place in the last operation of a function. This allows us to optimize recursive call without worrying about stack overflow error. To make a function tail recursive, you need to mark it tailrec. So you have this tailrec, and let's have the recursive call is uh, normal recursion versus tail recursive. What is this difference? Oh, so what he's saying is this is first calculated and then multiplied by n. The solution to this is you multiply by n first and then do the recursion. He's saying let this be the last operation. So he has converted this tail recursion into a straight function calls. But then how is so I do 5, so that is not equal to 0. Is going to do 5 into, and this function is going to call. So first this factorial 0 will evaluate, which will then give it to, then yeah, keep on popping things up until you go up from down. Now what is going to happen here is, also this n has come inside the, so when I know this is 5 minus 1, so then it's going to make another call which is 5 1 to 4 5, and then 4 5 is 320, 260, 120, and 0 120, and then last is we are going to result. Okay, so the what we do is in tail recursion, the recursive call is the last operation, and he's saying this, the recursive is going to be the last operation. But if you see here, the call has to be done. So you go down to the base case and then you pop in the stack. This will avoid stack overflow problem. Now, different ways of calling a function. Sometimes you need to call a function and provide only selected arguments. In Java, we could create multiple overloads of the same method, but the solution. So, saying how to call a function, like to. Okay, so to call a function, we need to evoke it. Default arguments are mostly known from C++ is one of the oldest. A default argument provides a value for parameter in case it's not provided. Okay, so if he's saying if I miss this parameter, yeah, he has provided the default, right? And then while calling is going to a named thing. So he's saying how to make the function call. Okay. Like what all are possible cases. So to make the first is default value in the parameter list itself. Uh, we provide a DVFA, we provide a default value. So if missed while calling, default is used. Then is using named arguments. Named arguments. So here is you pass in a named argument while calling. Then okay. Now is there a limitation like the last or any, this can be anything, right? Anywhere. There is no need. Sometimes you want to use a pass a value for the last argument. Let's suppose you want to define a value for suffix but not a prefix. Then so he has this function, right? Where is this print value? So he only wants to define values for the last two. By using named we can pass specific arguments using the so this value. So he's not passing this value here. But won't this give me an, oh, he's passing right string is going here. So these all have default values, right? So specific, yeah. Now then the next thing that comes is top level functions. Another thing that we can observe is that the main function is not okay. Okay, you already mentioned that we can define various entities of top level. A function that is a top level function. Here is an example. Top level functions can be used all around the code. No, what is top level? Then you have local functions. Okay. Now what are top level functions? Okay, so instead of where the function is defined, that is then something. So these are that are declared inside of any class, interface or object directly inside a Kotlin file. So you can have top of the file as well. Okay. Local function. Kotlin allows defining functions in many contexts. We can define functions at top level inside class, interface, and inside other functions. Consider the following example. So this is a function inside a function. These are called as local. So why is local? They are not accessible from outside. So you can only access this. Okay, so a function Elements accessible inside the local do not have to be passed from enclosing functions as arguments because they are accessible directly. For example, so what he's trying to say is, what if I have a parameter here? And he's saying this if I have a function inside this IDs is going to come from here, right? So he's saying there's no need to pass in because that is within the local scope. Inside. Okay, now there is. If you would like to define print log as a top level function, so this print log is a top level, then we would have to pass arguments both IDs and download it. So he's saying, and this is a local right now. What if I make this a top level? So let's say local functions. So functions inside the functions are and then and what he said is parameters, right? Local functions cannot be accessed from outside. And then what you need to do is local functions or parameters need not the local function defined inside. Okay. Nothing returned. There's something. If you want to define a top level function, then we'll have to pass an argument both IDs and download it. So what is saying? Uh, top level functions. We'll see this later on. No, nothing return type. Now, sometimes we need to define the function that is always throwing exceptions. The two real life cases are functions that simplify through error throwing. This is especially used in libraries. And then function is for throwing errors in test. This is useful when we are doing test handling. For this, there is a special clause. Clause is nothing. Nothing clause is an empty type, meaning it has no instances. A function can that has nothing return type won't return and will never use the return statement. It only throws an exception. So whenever you have the function, it will have nothing. It will just throw an error. So what's the advantage? the thing, it means it throws out exceptions, indicates that the function does not return normally. Okay. So you can this is okay. If the return type is nothing, so then we say that this function either will okay, nothing return type function. So this will throw error, infinite loop, and there are 2-3 cases, right? It will throw an error, infinite loop, or there is something which I missed. It will throw an exception loop, that's infinity, and then not terminate the program. Terminate program. Oh no, this is something important. This is where we start our oops. And then do we have so this is something important. What all topics does it show the index? Oh, we are here. Like this is we are here classes and objects. So then we need now it's not much. Do we have generics or something? Yeah, generics. So what does it do in this? Let's see. Oh, he's going to create something. That's nice. So you need to start with this classes and objects. Yeah, that's all for this lecture. See you guys in the next one. Thanks. Bye.